Alright, this video I'm just going to do some couple of quick examples with this distance formula. So let's say I have one point over here, and I'm going to let that point be 7, 3. And I have another point over here, and that'll be 3, 1. So I want to find the distance between 7, 3 and 3, 1. Well, so I'll call this point 2, and I'll call this point 1. So P1 is 7, 3, and P1 is 3, 1. That means, okay, so distance between point 2 and point 1 is going to be equal to, and we just use the formula from, well, we don't even really need to memorize the formula. All we have to do is recognize that this is going to be a right triangle, with the distance, the horizontal distance, being the difference between the horizontal displacements, and the vertical side of that triangle being the difference between the vertical displacements. Or take the square root of 7 minus 3. This is the difference between those horizontal displacements, or the x value of P1 is 7, the x value of P2 is 3, squared, plus, and then the vertical the vertical difference between P1 and P2 is 3 minus 1, or 2. So this ends up being 4 squared plus 2 squared. Or 16 plus 4, or the square root of 20, which can also be written as 4 times 5, or 2 times the square root of 5. Or the square root of 4 times 5, or 2 times the square root of 5. That's what I mean to say. Alright. But we don't have to take examples just from in the first quadrant. I could take example here, 4, 3, and then an example in this quadrant over here. So in this quadrant we'll have negative x values and negative y values. So I'll do negative 4, negative 3. Okay, so the distance between point 1 and point 2 well, now we can just do it. 4 minus negative 4 is going to be, so 4 minus a negative value is plus, so it's going to, well, I'll just write it out. 4 minus negative 4 squared plus, or we can just see the distance here. I know this is negative 4 and that's positive 4, so the distance is 8. 4 minus negative 4 is 8. You can do it that way. Or you just do it the methodical way. 3 minus negative 3. There might be some advantages to just learning, the method and applying the method each time. Or seeing what it actually is there's a distance of 3 here and a distance of 3 there. Or 3 minus a negative distance is going to be a positive, so 3 plus 3 is 6. So this ends up being 8 squared plus 6 squared, or 64 plus 36. Definitely didn't do that on purpose, but this is going to be the square root of 100, so I wasn't really thinking about it, or 10. And that makes sense because a 3, 4, 5 right triangle is similar to a 6, 8, 10 right triangle. And this is applying the Pythagorean theorem. I think I said that in the last video. So let's do another example. Just going to do one more example really quick and then we'll end the video. Let's say I take 1, 10. And then negative, it doesn't really matter, negative 3, 5. Okay, so now the distance between these 2 points, P1, P2, And actually, you know, it doesn't matter which one P1 and P2 is. It doesn't matter if I say 5 minus 10 squared. That's, oh, whoops. This is 10-1 is what I meant to write. 10-1. That definitely wouldn't have been on the right part of the graph. But what was I saying? So it doesn't matter if I take the values, the x values here and subtract them, and subtract these x values from them, or if I take these x values and subtract those x values from them, because I'm squaring that, and the distance is going to be the same anyways. What I mean is okay, I'll just start from this point and do that point, or I'll do negative 3 minus 10. And what I mean is that's negative 13, but since I'm going to square it anyways, it's the same as 13 squared. And 13 is the distance between them. So it doesn't matter if I'm dealing with negative distances, they're the same as positive distances in the distance formula. And the matter of negative is really just a matter of orientation, really. Like, which way is your positive direction, which way is your negative direction? Well, it just depends on what you choose it to be. So we have 5, I'm sorry, I was subtracting these values from those values, so 5 minus 1 squared, and we know the distance between those is 4, so that's good. So this ends up being negative 13 squared, I think that's 169, yeah, 169 plus 4 squared is 16. So it's the square root of 169 plus 16, or the square root of 185. And that might reduce, I'm not sure, but I don't want to let this video go on too long. I just wanted to do a quick example of how the distance formula is used.